the first videos for Math 1325 chapter 12.5. So this time we're going to look at absolute maximum and absolute minimum. This is probably the most important topic for application for the derivatives by finding the absolute maximum and minimum of a function. So economists may be interested in finding the maximum profit, and a doctor may be interested in the time it takes for a drug to reach its maximum concentration in the bloodstreams after an injection. A city planner may be interested in the location of heavy industries in a city in order to produce the minimum pollution for the residents and the business in the area. So in this section, we're going to develop a procedure needed to find the absolute maximum and absolute minimum of a function. And I will have this handout upload on D2L, so you can print that out if you want to. And basically, it say if f plug in that number is greater than or equal to f of x, then all of the domain in the x, then this is the absolute maximum. And if you have f plug in c is less than or equal to all the domain value in the function, then that would be considered as an absolute minimum. So looking at all these three functions with the graph here, so all of them are going from negative infinitive to positive infinitives. That means some of them are. The first one is like starting from negative infinitive to go to positive infinitive. The second one for the domain part is negative infinitive to positive infinitive. And the last one is also negative infinitive to positive infinitive. So when we look at these three graphs, and if we want to look at the absolute maximum and minimum, meaning the highest point and the lowest point of the graph, for the first one, I have no absolute maximum or minimum. And the reason is that because it's going down forever, I don't have a lowest point of the graph. And then it's going up forever, so I don't have like the highest point of the graph. They're going toward infinitive and negative infinitive. So the only thing I have would be those relative or local maximum and minimum. So I have, this is going down and up, so this is a local or relative minimum at x equal to 2. And then I also have a point which go up and down, so this is a relative or local maximum at x equal to negative 2. So for this particular graph, only local maximum and minimum, but no absolute maximum and minimum. Okay, for the second picture, it's going down forever for y value, but I do have a local maximum here, which is also considered as the absolute maximum because this is the highest point of the graph. So the absolute maximum is x equal to 0. We don't have an absolute minimum because it's going down forever here, so I don't have the lowest point of the graph, okay? For C, it looked like this is going on forever here, so I don't have a highest point of the graph, so no absolute maximum, but I do have the lowest point of the graph. So the lowest point of the graph is going to be x equal to 0, right? Can we see that? So we're just discussing the location of the absolute maximum and minimum. So this is one type of question you may see. And the second part is talking about the theorem for extreme value. So a function that is continue on a closed interval, so this is different, this time it's a closed interval, has both absolute maximum and minimum within the interval. So the next example is kind of an interesting one, I think. So basically, sorry about that, I'm going to zoom out a little bit and make it feel a little bit easy. It's not cooperating to zoom out, sorry about that. So what happened is all four of these graph is basing on this degree 3 function. So they have the same graph. The only difference between the four of them is they cut the graph in a different interval. So the first one, we are focusing on between x is 2 to x equal to 12. So they have two endpoints, right? So they start from x equal to 2 to x equal to 12. So this kind of graph, when you cut the function in a closed interval like this, they will have both absolute maximum and absolute minimum. Because I can find the lowest point, which is here, that is my absolute minimum point, f of x equal to y, right? So it means the x value is 2 and the y value is 24, right? F of x equal to y. And then I also have the highest point of the graph, which is when x equal to 12, y equal to 154, right? So for any function, if you pick a closed interval, you will definitely find the absolute maximum and minimum. So the second picture, they are using the exact same graph, but they're going to cut the interval in a different part. So this time, they're going to look at between x equal to 4 and x equal to 10, okay? So the highest point, so earlier, the last one, we have the lowest point and the highest point, right? And then this one, we have the lowest point look like here, and then the highest point look like here, right, of the graph. It's not necessary always at the end of the graph of the interval, okay? So the highest point of the graph is here, which x equal to 5, y equal to 105, right? That's my absolute max. And the lowest point of this graph, x equal to 9, y equal to 73, right? So that's my absolute minimum. Hopefully that makes sense to you. And the next picture, they are still using the same function, but this time they're going to cut it in a different closed interval, starting from 4 and end at 8 for x value. So my lowest point is this guy, which is my absolute minimum when x equal to 8, y equal to 78. And then my highest point of the graph is this guy when x equal to 5, y equal to 105. Alright, the very last one, again using the same functions, but they're going to cut the interval in a different part, which this time they look at between x equal to 3 to x equal to 11. So the lowest point look like they have two of them. They are at the same y value. So it's either x equal to 3, y equal to 73, or x equal to 9, y equal to 73. It's my absolute minimum point. And then for the highest one, it also have two. One is x equal to 5, y equal to 105, or x equal to 11 and y equal to 105. So both of these are your absolute maximum. So hopefully that makes sense. So we look at two set of graphs. The first three graphs, their domain is negative infinitive to positive infinitive, so they could have absolute max or minimum, but not always. And then the bottom one, even though the original function go on forever for the x value, negative infinitive to positive infinitive, but because you close to an interval and look at the graph, then every single one of them have at least one absolute maximum and one absolute minimum. Thank you.